Sparse autoencoders are used to control AI. How do sparse autoencoders work? I made an analogy so that I could understand it and teach as well. Sparse autoencoders, the way they work is you could imagine a grocery shelf that has a section for bread, a section for beans, etc. Kind of what AI does, though, is it might take a concept like bread and beans and put them in one location together. So what you could do is grab this cart and separate them. Like you could say section 1 is only for beans. And so you grab the beans here, and section 1, 2, 3 on the shelf has beans also. So section 1 on the cart is only for beans. So you can group those together. So I'm going to select beans, group these together. Now you have beans on this section. Then you could say section 2 is for bread. So select the bread and move it. Bread number 1, bread number 2. Now everything is separated. So part of the benefit of that is, just say if the bread and the beans, if you wanted to order more beans and not order as much bread, like you wanted to mark down some of the bread if it was fixing to go out of date in the next few days, for example, if you wanted to sell it before it went out, you could mark it cheaper. So what you could do is separate the stuff like it is now, and you could increase the order of beans and just not order the bread and mark the bread down. So that could be beneficial so that there's enough beans to sell, but the bread does not go bad. So that's kind of what sparse autoencoders do, and I can get into the detailed mechanics of it. So partly what they do is, instead of just bringing one cart and separating them like this, they might have multiple carts. And say if you have another cart over here, then you might have 1, 2, 3, 4, 5, 6 sections on that cart as well. I'll just do something like this for now. So you might have 6 sections on this cart as well. The cart I just showed that has currently the bread and beans in it. To start out, that could be cart number 1, and that could be for this specific section right here. Cart number 2 could be this purple one. That could be for the second section. Have another cart for cart number 3, for 4, for 5, and 6. So you have one cart for each section. So what you then do is say, just grab cart number 1 and put the beans and stuff real quick. And start this part right here to see how to do it in detail step by step. So bread goes here, the other bread goes here. So what you could do is start out and be like, okay, this cart right here, the silver one, is for this first shelf section. And this first shelf section, just say, has 2 cans of beans and 1 loaf of bread. So you could say section 1 on this cart is for beans, section 2 is for bread. So I can grab the beans from section 1 and beans again from section 1, put them together. Okay. And then section 2 is for bread, so I can grab the bread and place that here. But I'm only dealing with this first shelf hole currently. This whole cart right here is just for this first shelf hole. Okay, now that I'm finished with this shelf hole is empty. I can be like, okay, now I'm going to move to cart number 2, which is just for the second shelf, or second original shelf. So I can grab what's in there. And remember, section 1 on this silver cart is for beans, and section 2 is for bread. So the same thing for the purple cart. Section 1 is for beans, section 2 for bread. So I'll put section 2 on here for bread, just say if that's section 2. And there's nothing else left in here. So that one's complete. So you'd have another cart for section 3 and do the same pattern. Like beans, if there were any beans in section 3, that would go in slot 1 on the third cart. And if there was any bread, it would go in slot 2. If anything else, just say if turnip greens, if that was in slot 3 on the cart, if that was allocated for turnip greens, and if there were turnip greens in slot 2, or sorry, if there were turnip greens in slot 3, then you would remove the turnip greens from here and place them in its designated slot over there. So what you could think of it as, always, this cart, slot 1 is beans, all the carts. Slot 1's beans, slot 2's bread, slot 3 is turnip greens, etc. Each slot is for its own stuff. But each cart is just for one shelf hole, or one shelf section. All right, So now, just say if you did all 6 carts, a cart for this, cart for this, cart for this, this, and this. So you'd have 6 carts, and each of them would have 6 things on it. So now what you could do to simplify it is you could be like, create another cart. So come down here, and here's another cart, and could say section 1 of this cart is for beans. So you grab the beans from here, place it here. Beans from here, place it here. So you're grabbing it out of all the carts, the beans out of all the carts. Okay. Now section 2 on all the carts is for bread. So down here you could do something like bread, section 2, bread from this other cart, section 2, etc. And then you could complete all of it that way. So now you can get rid of these carts. So that analogy of getting rid of the carts is what's actually used in artificial intelligence, or some way to conceptualize it, because you don't want to have all this unnecessary clutter laying around. Like, all these carts are finished being used currently. This silver cart and this purple cart, so you could get rid of them. And let's see, whoops, wrong cart. You could get rid of that cart and the purple cart. So get rid of that one real quick. Pencil, do that. Close enough. Okay, so now left with this. So another thing you could do is be like, I want to describe, this is where the analogy kind of fades off, but one way that the AI does stuff is like, part of this analogy still holds. The beans, you could describe the beans in a whole lot of different ways. Just say, have another cart. See, where's a new cart? Yeah, that one. Have a new cart, and just say you want to describe beans in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways. So you could use this and describe beans in 12 different ways with this cart. So you could grab the beans and could say, okay, beans, they are a category of food called legumes. So just however you spell legumes. And let's see if I can, yeah, legumes. They are not meat. So just if the second section was talking about, is it a type of meat? It's not, so it would be a low amount. But instead of having letters like L or whatever, it would actually have numbers. So I'm going to erase that letter. It'd be like, how much out of 1 to 10, for example, are beans legumes? And the AI might be like, yeah, they are legumes, and it's 90% sure, or 9 out of 10 sure. Are they meat? It might be like, it's about 10% sure it's meat. Are they a type of, are they grown in gardens? It could be like 7 out of 10 likely it thinks that they're grown in gardens, etc. And so you could it would fill in description of beans in 12 different ways. Like this first section could be, are they legumes? Second, are they meat? Third, are they grown in gardens, etc. So this way you're deeply describing the meaning of beans. So what you could do, let's see real quick. Oh, actually, sorry, this should be 6, not 12. So just forget that part. So this is 6 ways to describe beans. So what you could do then, just say if this is 3, whatever that is, this is 5, and this is 1. So now you have 9, 1, 7, 3, 5, 1. So now, if you want the AI to talk more about beans, what you could do is do like this. Let's see, I want to adjust the size of this. You could be like, I'm going to add the description of beans to the original shelf stuff. I'm going to add, hold on just a second, click on this. Yeah, I'm going to add 9, 1, 7, 3, 5, 1. Okay, so put this back like it was originally to show that what it's actually, sort of what it's doing. So move the bread back too. See, this bread goes here, and this bread goes here. I think that's where it was originally. Okay, so now you've added the 917352, which is the multi-description of beans, to the original shelf, all the shelf sections. So now, when the AI predicts stuff, it will be more likely to predict the concept of beans, because the idea of is it legumes is higher because you added 9 to it. Just say if the beans value was a certain amount or whatever. Anyway, you added 9 to it, and the idea of whatever else describing beans, like is it a meat? The meat thing is lower. The next thing is higher, etc. So on. So now, whenever you ask it a question, it should talk about beans or the concept of beans more. For example, just say if you say, write me a love story, it might, without changing it, like originally, the thing might say something like, there was a couple who met at a restaurant and they had a enjoyable conversation and they had a lot in common and so on and so on. And they fell in love and lived happily ever after. But once you add the beans concept, you could say, write me a love story. It might say something like, there was a couple that met at a restaurant and the waiter said that the special was enchiladas, rice, and beans. And they both agreed that that was their favorite food. And especially the beans, because they both had farms when they grew up, and beans was the primary thing they grew. And so on and so on and so on. And they both started a farm, grew beans and other food, and lived happily ever after. So see how it would start implementing the concept of beans more and more and more. And sometimes it's not just the word beans. It might be stuff like to do with beans, like legumes or something like that it might talk about. But it would start talking more about the stuff to do with beans, because it has the description of beans, which is the first section, is it legumes? It bumped it up by a higher number. The second section, is it meat? It drops it down to a low number, and etc. So that's sort of how sparse autoencoders work, and that's partly how you can control a transformer in artificial intelligence. So a sparse autoencoder, you can train it where the target data is actually the input data. So what it does is the input data will go through a neural net, and it'll have an encoder and a decoder. And it should output what the input was. So what it does is it'll break it apart into bigger sections. So just say the input is, this is the input. Then it will go sort of like these, or one of the carts, or some of the carts, they were way bigger. They had more sections on it. So just say this connects to here, 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 and here. Then you have these three connecting to that, 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 and these three connecting to that. That looks really cluttered, but so what it's doing is it's taking these 3 things and breaking them apart into 5 things. So that's sort of like the breaking apart the things that are on the shelf, because there might not be enough room with 3 sections. Just say if you have 4 ideas or 4 types of food on here, 4 types of food, but you only have 3 sections. So it combines the things together in what's called polysemantic neurons. Poly means multiple in I think it's the Greek, and semantic means meaning. So it's a single neuron that has multiple meanings to it. And you want to, by breaking it apart like this, you convert it into monosemantic neurons. And each neuron or each dot can have its own meaning. Like this one can mean beans, this one can mean bread, and so on. And so just say if you have more concepts than can fit in these 6 sections, like if you have 10 concepts, then a sparse autoencoder could break it apart so that each section or each concept has its own section. 6, 7, 8, 9, 10. So each of these could have its own section. And it would actually have a lot more typically. That's why it's called a sparse autoencoder, because there's a lot of empty shelves. Part of the reason for that is to make sure that you have enough to break it apart into however many pieces so that each concept can have its own neuron. So that if you want it to talk about beans more or less, then you can adjust the values based on the specific neuron. So what you actually do in practice is take the decoder. So you have simplify it, you have the inputs, and that breaks apart into a whole bunch of values. And then, so what this does is it's matrix multiplication, which matrix multiplication is groups of dot products, and dot products are multiplication and addition at their core. So most of the calculations in artificial intelligence are multiplication and addition at their core. So just say if you have, it breaks apart these concepts using the encoder. So just say two concepts, and it breaks apart into all these neurons. So you originally have two neurons, and they break apart into more than that. So then you have a decoder that converts it back to two neurons. So converts back to two neurons. So you actually take that decoder and add part of that back to the original, what's called the residual stream inside the transformer. You can check out some of my other videos to see how transformers work. So whenever you add that back to it, then it's more likely to start talking about that concept, like such as talking about beans more or whatever concept. So partly how that's useful is just say if you're training AI to do something like drive a vehicle based on where you tell it to go. If it tends to go to certain types of locations more than others, and it's a type of location that you don't really prefer, if it keeps doing that for some reason, then you could figure out possibly where the neuron is or the sections that control it, and then decrease the value of that and increase the value of the type of place that you want to go to more. Like, for example, if you say go to a nice coffee shop, if it takes you to some kind of big shopping center with lots of traffic or lots of vehicles in it, and you prefer to just have a small local coffee shop type of thing, then sparse autoencoders could be used to make it where it goes to the type of shop that you want more. You just add the value of the small shop and subtract, I guess you could say subtract the value of the large crowded coffee shops, and etc. So anyway, that's and there's way more important things too it could do, like if it eventually got super powerful and so on, then you'd want it to be able to, control it in the right directions. So like if you have a powerful piece of machinery like a tractor or something like that, it's good to be able to, control it in the right directions. So anyway, that's how sparse autoencoders work. And if you have any questions or comments, let me know. And thanks for watching. Please click like and subscribe.